Hello and welcome to the Oracle Database world. If you've been considering migrating your workload to the Oracle Autonomous Database, then this is the right session for you. My name is Chris Panushali. I'm a Senior Principal Product Manager here in the Oracle Autonomous Database Product Management team. And today's topic is best practices for database migrations to Autonomous. Our agenda today is straightforward. I'll be giving you a quick introduction to the Autonomous Database. We'll be talking about pre-migration considerations, things you should keep in mind before you start the migration process or before you make migration option choices. We'll talk about the options that are available to you based on your source database version, source database platform, operating system, and also the type of target autonomous database you choose. And then finally, I'll leave you with some resources for furthering your learning. Now, the Oracle Autonomous Database is the Oracle database offered as a simple-to-use cloud service where a lot of the functions are automated, especially the admin tasks. To begin with, the provisioning of the database itself is very simplified so that if you're a developer, you're a DBA, a line of business user, and even if you're somebody who is responsible for deploying complex mission-critical database configuration, you can do all of that very intuitively from a simple web UI or programmatically through APIs and SDKs that are provided. And so provisioning has been highly simplified from the basic to the most complex configurations. And as I said, it's autonomous in nature. A lot of the admin functions, such as backups, patching, availability in case you decide to replicate across regions, encryption key management, all of these functions are now automated and then basically very simple to configure and use. The service is also designed so that it responds in real time to workload demand and scales up or down in terms of the resources that it consumes. Now, this way, it gives you true dynamic pay-per-view in real time without any downtime, which means that when you size your database, you are no longer going to size for peak workloads. You will size for an average workload and allow the system to scale up to 3x the max size that you have configured. And that headroom can be used on demand only, and thereby saving you cost and CPU time on an ongoing basis. The Autonomous Database also runs on a variety of platforms. It can run in one of the 32 public cloud regions worldwide. It can run in your own data center if you so choose. It can also be brought to a special region that could be built for your company in case you desire. Now, let's quickly look at the target platforms. And the reason this is important is the migration options you choose could be dependent on the type of target autonomous database platform you're on. So the simplest of them and the most easy to use, lightweight autonomous database option is on the shared platform. And by shared, we mean the infrastructure on which your autonomous database is hosted is shared between customers. So all autonomous databases, by the way, are deployed on Oracle's Exadata infrastructure. So as you know, Exadata, for over a decade, it has been a platform of choice and a highly performant platform for deploying Oracle databases. So shared, dedicated, and cloud customer, all three are deployed on Exadata. In shared, that Exadata machine might be shared between different customers. So in a container database, multiple pluggable databases could belong to different customers. If that option works for you, then you definitely get all the other benefits that I mentioned of autonomous, of automatic patching, key management, security, etc. If your application requires its own dedicated hardware and it requires more isolation in terms of performance, network, and of course, hardware isolation, then a dedicated Exadata infrastructure could be a platform of choice for that application. And so you can then deploy autonomous on dedicated in once again, one of the many public cloud regions. Now, certain applications may also require that the infrastructure actually stay on site. And so due to either data sovereignty issues or because it integrates with other applications on premises for a variety of reasons, if you choose to run autonomous in your own data center, then you would pick the Cloud@Customer platform, where an Exadata cloud machine is then deployed in your data center and you run autonomous on it. The advantage is you get all the benefits of cloud. You get the same console interface, API interfaces, except the hardware runs in your data center. So now, with an understanding of the different target platform choices, let's move on and look at some of the pre-migration steps that you would undertake before you make a choice on the migration technique. A little bit of background on how autonomous works for you to better understand what these checks are about. Now, autonomous, as I said, is built securely so that different workloads can run on a single container database or a single Exadata infrastructure. Also, it provides isolation between the pluggable databases. And so basically, if you're running an application on a pluggable database A, it should not interfere with something that's running on B. Also, from an access perspective and a security standpoint, the users of one database should definitely not have access to another database. And therefore, even in a large organization where hundreds of such applications might run on a single Exadata infrastructure, you get isolation between all of the different applications at different levels. And for that purpose, many of the functions of the database or the features of the database parameters that can potentially compromise that are locked down, right? And so it's important to understand what those features are and make sure that if your existing application has those parameters in place or is set up in a certain way that can interfere, then you identify those and you can resolve those ahead of time before you decide to migrate. And so one of the migration checks is to basically look at legacy features, right? And then understand how they're handled. There are some examples of them on the slide. For example, if you're using basic lobs, then they are converted to secure files when you do that migration to autonomous using the data pump method, which we're going to discuss in future slides. Also, the way you manage table spaces, the way you manage extents, the way you manage DBMS jobs changes slightly. So there are some objects that basically automatically migrate themselves to a new form. And so you need to be aware that that happens and then ensure that your application can handle that. Similarly, there are certain features of the database that may not be supported in autonomous. And for the reasons that I mentioned earlier, application containers, common users, data masking and subsetting pack, sharding. These are some of the features of the database that you might have on-prem, but these are not available in the autonomous database. And so if your application has been using those, you make sure that either they are removed or there is no such dependency on those features before you migrate your data into autonomous. Now, all of this could sound super complicated and hard to keep track of and uncover. And therefore, we provide a tool called the Cloud Pre-Migration Advisor tool, or fondly known as CPAT. What happens with the CPAT tool is once you run it against your source database, it will validate all of these parameters, options, features, objects that might be in certain places. And then it'll generate a report and let you know if your source database is ready for autonomous. An example is if you have objects in the system table space, clearly that is not allowed in autonomous. Customers do not have access to sys and system, and therefore it will flag those changes. And so it just really makes it simple for you to basically understand if your source databases are ready. The tool itself, it's Java-based. And so if you have any restrictions on not being able to run it directly on the source database, then you can actually run it anywhere and it'll make a JDBC connection to your source database. It'll determine what it needs to find out, and then accordingly it'll generate a report, which can either be in JSON or it can be a text output. And so if you have dozens of such databases you're running against and automatically, and then you would later on want to do some sort of a key value search, you might actually pick JSON. So that option is available. If you use the ZDM tool, which we're going to talk about as one of the options of migrating to Autonomous, ZDM does come bundled with CPAT, and so as a precursor, the first step, it'll automatically run CPAT and determine that your source database is indeed ready for migration, and then it'll carry on with the following steps. Okay, so now we get into the migration methods. First of all, when it comes to Autonomous, all migration is logical. So you have to understand that you will be migrating the data and not the database, right? So you cannot take data files themselves and move them to Autonomous, which is very typical in a migration, whether you're using transportable table spaces or RMAN-based physical migration. Those options are not available to you. You actually have to take the data and move it to the Autonomous database. And there are two different paths, as you can see in the slide. The first path is very direct. You have a source database to which a tool can connect, and it can move the data to the target database. The other option is where, mostly for databases that would be larger in size or have availability restrictions, is that you would take the data, you would stage it in an object store or a local storage, and then from there you would move it to the Autonomous database. So you have two distinct paths and two distinct methods, and a lot of the tools that I'm going to talk about are one or the other. So that way you'll understand what the differences between the two tools are and where you should use one versus the other. So here's your options. Now, all the options in the top row are pretty much for direct load, right? So we'll go, over each of them, and I'll explain which one you would pick based on the type of use case you have. But database actions, SQL Developer, and SQL Loader pretty much load data directly from your source database into the target database. Except SQL Loader, maybe. I think SQL Loader would require it will load data from a flat file, so you will somehow need to get the data out of the source database. Data Pump, ZDM, Data Migration Service, they are, again, would require staging of the data, and they are generally intended for workloads where the database sizes are substantial, and then you have other restrictions on the availability of those databases. So, and those are some of the key migration techniques, and so we'll spend a little bit more time on those. So let's talk about database actions. Now, this is a migration tool that is available in the OCI service in the database console itself. So if you go to the OCI database console, in your Autonomous service, you will see one of the tiles there that says database actions. And it is basically meant for, quick loads of small data sets into your Autonomous database for dev test, if you're trying a sample schema, etc. So anything that is lightweight, give or take a few megabytes, it's a good option. It's available both for public cloud and cloud at customer, and it works on a variety of source data formats. You could be loading data from an Excel spreadsheet or CSV, or a JSON file or an Avro file, etc. Now, many of you might be familiar with SQL Developer, so this could be a favorite tool. And it also handles slightly larger files than database actions. Once again, SQL Developer has been used by users, DBAs, developers equally for a long time. And so, of course, the learning curve is really very small. You would use it for loading medium-sized data files directly from your SQL Developer tool basically which you can install on your laptop or your desktop. And it works with a variety of formats. So I wouldn't speak much about that because I'm sure many of you already know how to do that. SQL Developer has been enhanced so that it works quite well with cloud databases, sets up a secure connection using a wallet that you can provide, and is very intuitive when it comes to loading these files into a cloud autonomous database. Then comes SQL Loader. Now, SQL Loader is unique in the sense that you can use it to load files from either object store or from an NFS device, depending upon whether you're using a public cloud autonomous database or Cloud at Customer. So let's take Cloud at Customer, for example. If your Cloud at Customer is on-premise in your data center, and you decide that, of course, your data should not leave your data center, you may not want to put it in the object store. And it makes sense to first download your data to flat files, and then use SQL Loader to load that data into your database. So your data files could be sitting on-prem. Also, you can download data from a variety of databases, and as long as you have them in CSV or text files, you can then upload these into your autonomous database using SQL Loader. Then comes the golden horse of data loading, Data Pump. And Data Pump, again, is unique because it supports a wide variety of source and target platforms. Of course, it is limited to an Oracle to Oracle data migration, but if you're running an Oracle database on-prem, it could be running on a different operating system. It could be running on a different Indian platform, different version of the Oracle database. As long as that version supports Data Pump, you can actually take a Data Pump export and then move those files to where your target is and load them. Now, the only requirement, as I said, is that your source does support Data Pump. So again, you basically all the way from 10G is when Data Pump was introduced to 21, you could have a wide variety of sources from which you can export and move data. It is also a lot faster, and it is also good if your databases are large. So you could have terabyte-sized databases that can be migrated into autonomous. If you're moving into autonomous on dedicated Cloud at Customer, then you could use the NFS option where Data Pump files could be put on a local NFS in your own data center and then imported into the autonomous database. If you're using public cloud, then you're better off moving those Data Pump exports to OCI object store and then importing it from there. The only consideration when it comes to Data Pump is the fact that if you have a very large database and you download it, you need a certain amount of downtime. So for databases that could be down, for example, a day, a weekend, those can be a great way for simple Data Pump export and import into your target or a data warehouse. And so where availability, I would say, is not a major criteria, doing a simple direct Data Pump based export import could be a good option. Now, then comes applications where availability is a criteria, right? You have business critical applications where downtime is minimally available, or you may have just a brownout available, 24/7 applications. All those can be migrated to autonomous using a utility called Zero Downtime Migration, or ZDM. So ZDM is an Oracle provided free utility that helps you move from a variety of source databases to a variety of target databases, not only autonomous, but even many other types of platforms, Exa Cloud at Customer, Exa CS, etc. In fact, there's a whole other session on ZDM that is being done by my colleague at Database World. I would ask that you check it out if this tool is of interest to you. But talking from an autonomous standpoint, it simplifies a lot of the tasks that you would have with data pump, running pre-migration checks, setting up availability. So it uses the MAA best practices of Oracle using Golden Gate to ensure that it is moving trail files to the target and does a cutover such that the downtime is close to zero. And so let's take a closer look at how ZDM works step by step. Now imagine you have a source database that requires high uptime and it is constantly being used by end users. To migrate this database, of course, you would first go ahead and create an autonomous database on the target platform of your choice. Could be Cloud at Customer, could be shared, could be dedicated infrastructure in the Oracle public cloud region. So whatever your choice is, go ahead and deploy your autonomous database. Install ZDM on a host. All you need is a Linux host. The footprint is very small. It's about an 800 MB binary. So it takes very little to install and run it. Also comes with its own CLI, etc. So it's easy to configure and fire off. Once you have ZDM running, it can establish a connection to both the source and the target, make an SSH connection to your source so that it can take the data pump exports. It can make a SQL connection to your autonomous target database. Next, you would set up a Golden Gate microservice. Now, this is also very easy to do because it's readily available in the OCI marketplace. All you have to do is go there and deploy the microservice from there. Once you point ZDM to it, it knows how to configure Golden Gate so that it can pick up the trail files from the source database and then apply them on your autonomous when needed. So the entire orchestration is done by ZDM. All you do is deploy autonomous database, deploy Golden Gate, and then you configure ZDM and give it the information it needs to connect to these systems, including your source database. And so basically, ZDM starts once it finishes taking the database data pump dump files from your source database. It will start moving them to the object store or to an NFS, depending upon what you have chosen. Once it completes that movement of data, it will start applying the exports to your autonomous database, which is kind of the initial load that it completes via data pump export and data pump import. Once that finishes, it orchestrates Golden Gate to start applying the trail files that it has accumulated, right? So now comes the time where your autonomous database is keeping in sync with your source databases until a time that you are ready to make the switch. And so when you're ready to make the switch, you would then go ahead and move your applications or your user to the autonomous database. And with a brownout, basically you have completed the migration. So that's ZDM. And as I said, it's a great tool with options to migrate from a variety of source to target database types. And if I've not said that before, once again, it is free. And so do check it out and do check out the session on ZDM for more details. In ZDM 21.2, you also have the option of migrating, doing an offline migration from AWS RDS to Autonomous. So if you've been running an Oracle database in AWS RDS service, and if you desire to move that database, then you can use ZDM to automate a lot of that migration via S3 service. So it takes a data pump export, moves it to S3, and from within S3, you can import it directly into the autonomous database. Similarly, if your source database is on AIX or on Solaris, so other platforms than Linux, you can use ZDM 21.2 and complete the migration, a logical offline migration using the same method that I've described, using data pump as the underlying technology. And finally, there is an OCI service called the Database Migration Service. Now, the Database Migration Service does automate a lot of these things under the covers, and it's a lot simpler to use, except it only works for migrations to autonomous databases in the OCI public cloud regions. And so it does not currently support Cloud@Customer. But if your target is one of the public cloud regions, it is a great tool, doesn't require installation. It is there. You can, and it's quite intuitive. So when you go there, you configure it to connect to your source databases, provide an autonomous database to connect to, and you can complete the migration in a few easy steps. But the tool is being enhanced, so future versions of the data migration service will allow it to support Cloud@Customer as well. All right, so to summarize, the best practices, we've talked about quite a few. Always run the pre-migration advisor or the CPAT utility on your source database, either via ZDM if you're using it, or by running it independently and ensuring that your database does meet the requirements of autonomous. There's a lot of documentation. If you go to Oracle's Autonomous Database doc, you would find a detailed list of parameters, parameters and features that may not be supported. So I encourage you to go take a close look at that, and that's an easy way to ensure which source databases are qualified to migrate to autonomous. And once you do that, then of course you pick the right option based on the size of your source database, the operating system, the version, etc., as we discussed, and of course the availability requirements of your application. Some resources, as I said, check out Oracle Live Labs, where you do have quite a few labs available. In fact, there's a great lab on ZDM, which you can try out, which will walk you step by step through all the steps you need to get to the autonomous database. You, of course, have the documentation for both ZDM as well as the autonomous database. And there's a special chapter on migration where all of these options that I mentioned are easy to navigate, and you can basically pick an option based on the use case. So there's a navigator in the doc itself. And then, of course, there's various blogs. One of them I've pointed out here. So with that, I wish you luck, and hope you have great other sessions at Oracle Database World.